Hello, hello, and welcome back. In this example problem, we are finding the area of a triangle with the given vertices, and we're going to use the cross product to do this. So remember that the cross product of two vectors gives the area of the parallelogram formed by those two vectors. So I'm going to play around a little bit with GeoGebra and try and visualize this thing. So one, you could plot these by hand, or you could jump into GeoGebra and plot there, or Mathematica, or your favorite mathematics software. You can do either any of this. So I'm going to jump into GeoGebra. And what I've done so far is I have plotted my 3 points, and I've drawn 3 vectors between them just so that we can visualize the triangle, because GeoGebra doesn't have an easy just make a triangle out of 3 points command, or at least I haven't found it. If you have, that's great. So I've just sort of made these 3 vectors between the points just so we can visualize the triangle between them, and we want the area of that triangle. Okay, so how do we get the area of that triangle? And remember that the cross product gives us the area of the parallelogram. So if I do, say, PQ cross QR, that gives us the area of the parallelogram. If I go PQ, QR, minus PQ down this way, and then minus QR like that, it'll make a parallelogram. And it'll give us half of that, or it'll give us that area. So one thing I want to do when I was playing around, just to visualize this better, is I wanted to find the other vertex of that parallelogram just so I can draw it in GeoGebra and visualize what area I'm finding. So in order to do that, I needed to take this vector PQ and sort of move it along QR so that its head is at R. So what I wanted to do is I wanted to find a point S over here that is starting at R, going down parallel to QP, going down like this. So how did I do that? Well, I found PQ, so let me jump back to my other scene. Let's see how I did this. I found PQ, and I think I did this in the last video as well, but maybe you didn't watch that. So I found PQ. It went, down 3, 0, and 2. And then I wanted the point S so that SR was the same as PQ. So how I did that is I moved in this direction from R, or rather in the opposite direction as this one, because I want to go downward. So negative PQ, I wanted to go downward. Negative PQ is 3, 0, negative 2. And then I moved this vector from the point R. So I'm going to define S, the point, to be 3 more here. So that's 7. 2 more, 0 more in the Y, so I still have 2. And then negative 2, so 2 down from 5, that's 3. And I'll plot that point and just show you that that indeed worked the way I imagined it. So S I have right here is 7, 2, 3, as I just calculated, and it's over here. And so that's the other vertex of this parallelogram. Now if I drop these other vectors in, maybe it'll be more obvious. So now we have those vectors, so that's my parallelogram. So that was how I moved this vector PQ sort of over here and made SR, were those calculations that I just did. And now we have the whole parallelogram. So if I do PQ cross QR, let me do cross PQ, what's my PQ called again? PQ is U. Oops. U, and then V is my QR. So if I do the cross product of those two, the magnitude of that vector there, so that is what? Magnitude of W, so mag. Can I do magnitude? Does that do it? No, it doesn't. I'm not going to worry about that. I'll calculate that myself. But the magnitude of that vector is the area of this parallelogram. And then if you notice, the triangle, what we're after, the triangle between PQ and R, is exactly half of that parallelogram. That's how parallelograms work. So if I can find the area of the parallelogram and then take half of that, that will give me this, the area of this triangle between PQ and R. So that's the idea. Let me jump back here. We have our plan of action, and now we're going to execute it. So what I want to do is I want to find PQ cross QR. And I don't want negative area. I'm dealing with positive area here. There's no notion of negative area yet here. So I'll take whatever the absolute value of the magnitude I really just want the magnitude of PQ cross QR. That's what I want. So we actually did PQ cross QR in the last problem, but I have since deleted that. So I'm going to compute that again in case you maybe didn't watch that video. If you have, just fast forward. I'm going to go through the calculation of PQ cross QR again. So PQ, that was -302. And then QR, that is what, 6 over 1 in the J and 2 in the R, or 2 in the K. So compute the determinant of that. So this is in the I direction. It is 0, 2, 1, 2 minus J times the determinant of -3, 2, 6, 2 plus K times the determinant of -3, 1, 0, or -3, 0. 6, 1. All right, so let's calculate that again. Again, if you're fast forwarding, that's fine. This is 0 minus 2, so this is minus 2i. I believe we worked out this was plus 18j, right? Minus 6, minus 12, that's negative 18. Negative here, that's plus 18j. And then k, we have -3 times 1, that's -3, minus 0, so that's minus 3. Okay, and we want the magnitude of this. So I really should have magnitude bars over all of this, and I want the magnitude of this one. So now we just have to find the length of this vector. So that's going to be square root of 2 squared plus 18 squared plus 3 squared. I got my calculator here with me, and I'm going to go ahead and punch that in. So 2 squared plus 18 squared plus 3 squared, and take a square root of that. And our answer should be positive, indicating the magnitude of the cross product, 18.357. I'll just round off here, 6. And so remember, this is the magnitude this is the area of the parallelogram. And so half of this is the area of the triangle. So divide this by 2. So area of triangle PQR is 1/2 of the magnitude of this cross product. And so that works out to be 9.17. I'll round off here. 9.179 is the area of the triangle. So pretty cool. Using the geometry of the cross product, we can find areas of triangles. And then remember, in the last problem, we found a perpendicular to a plane. So these, especially the last video, is a sort of stepping stone for a sort of bigger problem that we're going to work on later. But this is good for now. Thanks for sticking with me. In the next video or two, we're going to look at some applications of the cross product, so revisit torque and see some other cases of that. I'll see you there.